My name's Rob Meyers. I was one of the founding faculty here at Perimeter. I've helped build the organization from the ground up. And in fact, I've served as the director of the Institute. But I'm also a researcher here, a member of the Quantum Fields and Strings group. And my interests are in gravitational physics and quantum theory. And so I'm interested in working towards a unified framework that's often known as quantum gravity. I was always interested in science very broadly. In high school I took chemistry, biology, physics. But as a youngster I was also very interested in the space program. And I'm old enough that I was growing up when they were sending people to the moon, and that was all very exciting. And of course then there was science fiction, there was Star Trek and all of these things. But for my studies, I think at the end of the day I went after physics because it was the biggest challenge. It was the hardest one. Yeah, it was just fun. So that's about it. Well, often I find myself giving advice to students who are thinking about starting a PhD in physics. And the most important thing, I think, is that you find your passion. More glibly, what I say is make sure that you're going to be having fun, because you're going to devote many years, many hours, a lot of energy into understanding and researching a specific topic. And so you want to be sure that you're really passionate about that idea, about that field, because that passion will carry you through all of those hours, all of that sweat, all of that hard work. And really that'll bring you to the place where that you're succeeding in your field. Let's see, if I wanted to explain what I'm doing to a person from the general public, I would start talking about where has physics brought us today? And there's really two key foundations. There's quantum theory, which is a theory that describes physical phenomena at the very smallest scales, at the scale of atoms and even smaller. On the other hand, we have Einstein's general relativity. It's a beautiful, elegant mathematical or geometric theory that describes gravity. And that's really a theory that describes phenomena or physical processes at much larger scales. I mean, that's what's keeping me in my seat here. It's what governs the orbit of the Earth around the sun, how galaxies form, how the cosmos is expanding, how the universe evolves. And so we believe that there should be a single theoretical framework that should encompass both the quantum theory, which governs the small scales, and gravity or general relativity, which governs, astronomical or very large scales. And, that's really what my career in science has been about to a large extent. It's, working towards that goal of unifying those two theories. And that theory is something that we call quantum gravity. But it's, one of the deepest or most challenging questions that theoretical physicists have faced. They've been struggling with this question for over 75 years now. And yet that's a question that, I'm excited about, and we see new ideas, new directions, new developments coming in all the time. And so that's what keeps me going in my research program.